This is my latest retractable lightsaber. Featuring an instant extension, the brightest, most realistic blade in the world, and full retraction, it does all this in a replica Graflex hilt. That's right, replica. The same base hilt that they used in the original Star Wars movies. Even better, like many of you asked for, you can now lightly duel with it. To be honest, a retractable lightsaber with all these features and a replica hilt is something that I thought was impossible. So how did we do it? How does it work? If you've been following along on our lightsaber quest, you'll know this is not our first attempt. I've loved Star Wars since I was a kid, so I've always wanted to make a real-life lightsaber. For the past few years, that's exactly what I've been trying to do. What started as a literal rectangular box turned into a working prototype with V1 and extended even better with V2. But with V2, we still had things to improve. Namely, the hilt was ginormous, not made of metal, and not duelable at all. That was in June. I've been hunkered down since then developing this next lightsaber non-stop. The first problem was fairly obvious. How the heck can we fit all of this into a replica hilt? This is the Graflex hilt that we're trying to fit everything into. It is tiny. That's freaking awesome. Shout out to Cal from KR Sabers and the Saber Armory for the hilt. This is such a sick replica and works great for our lightsaber. While it's perfect and screen accurate, that means we had our work cut out for us. We have insanely limited space to fit in our mechanisms. Our previous mechanisms would definitely not fit, meaning we had to completely redesign the mechanisms and internals. So that's what we did. Here's a quick rundown. We're now using a clear magician's cane for the extension/retraction, with a single high-powered chip-on-board LED strip running through it to provide the light. The magician's cane basically acts like a really long spring that can compress to a really small size. The LED strip is attached internally to the top of the magician's cane. By controlling how much of the LED strip we let out, we can control the length of the blade. The LED strip is stored on a spool. When we want to retract the blade, we activate this attached motor, which spins the spool and pulls the LED strip back. At the base of the hilt, we have another motor that spins the entire chassis, and thus the blade at high speed, providing the awesome optical effect of a bright, pulsing, energetic blade of light. That's how we hoped it would work anyways. The first thing we needed to check is that the new blade setup provided a realistic blade effect. We had no space to run the LED strips around the cane as we did before, so we had to run it through the middle of the cane and make the cane clear. Without the spinning, it looked pretty underwhelming. But once we did spin it, it looked awesome.
That looks sick, actually.
Next, we wanted an instant extension for the blade, so like before, we used the clutch system. When the clutch is pulled back, the blade releases and shoots out instantly. When the clutch is pushed forward, it re-engages the gears and allows for retraction of the blade. After redesigning the clutch to fit into our new hilt, we tested to make sure that it worked. Spoiler alert, it didn't at first.
They're charging.
After a lot of modifications though, we finally got it working how we wanted. But we ran into another problem. Something not a lot of people know about magician's canes is that you can't just push it in to retract it. You have to push it in while rotating the base as well. We needed a mechanism to rotate the base, and for that we settled on this internal gear system powered by a motor. As usual, it didn't work the first time, or the second time, or the third time, but after changing a few things and quadrupling our voltage, it was finally working how we wanted it to. However, we ran into yet another problem, the stiffness of the blade. Since we switched to a clear plastic magician's cane over the steel cane we used previously, we've lost some stiffness. So how did we fix this? After a lot of testing, we found that you can actually stiffen the blade by rotating the cane really quickly.
That's cool.
And pulling it down at the same time. This tightens the cane segments together and encourages them to stay straight. But even with these measures, we still had to improve the stability of the blade, so we added a stabilizer.
So I have been testing these blade stabilizers for like the past couple of days now, and it's a bit of a problem because the magician's cane keeps catching on these little plastic parts. I'm trying to solve that while also making the stabilizer stiff enough to actually stabilize that kind of heavy cane.
This holds the blade in place and stops it from bending or moving around. We went through a lot of iterations and simulations of this stabilizer, but thankfully this was made easy due to Onshape. Onshape is our CAD software of choice and the sponsor of this project. It's the only CAD program that lets you collaborate in real time with other people. And let me tell you, this feature is why we're able to develop lightsaber iterations so quickly. With multiple people working on CAD at the same time, our design cycles are significantly shorter, which translates to much quicker project development. It also has version control just like Git, which means we never lose any progress on our CAD. It's super easy to keep track of design history and test different designs at the same time. Being cloud-based, it runs instantly on any device with no downloads, so collaborators can get set up quickly and get to CADing in no time. Onshape updates every 3 weeks with new improvements and new features. Some notable ones are simulation, Cam Studio, and rendering. You can even use Onshape on your phone. Super helpful for on-the-go design feedback and collaboration. Engineers and their companies can try Onshape Professional for up to 6 months, in addition to the free hobby and student accounts. If you're interested, a link to join Onshape is in the description, so check it out, and big thanks to Onshape for sponsoring this project. With the mechanical parts designed and tested, we moved on to the electronics. We're using a Profiboard V3.9 to control everything, 4 motors, 1 high-powered chip-on-board LED strip, 1 speaker, 1 3.7 volt LiPo battery, 1 14.8 volt LiPo battery, and curiously 1 reed switch. Why a reed switch, you may ask? Great question. For the last lightsaber, we used an external circuit with its own motor and battery to spin the chassis and blade. However, this was a bulky solution. As you can see, it sticks out of the hilt quite a lot. That's when me the mayor commented and suggested we use a reed switch. A reed switch is a switch that is activated with magnetic fields, so when a magnet gets close enough to it, it will turn on, and when the magnet gets far away, it will turn off. Perfect for our use. This meant that we could have the reed switch wired to the Profiboard inside the internal chassis, and just use a strong magnet on the outside hilt to trigger the lightsaber. This saved us a ton of space, thanks me the mayor. After verifying the electronics worked, we got to soldering everything. And we also wrote the code. So finally finished the code, writing a custom prop file. Things are working. Shout out to Olivier Flying 747-8 and Frederick Hubinet for help on the code and answering my questions. With the code written, it was time to put everything together and start testing. What could go wrong?
Okay, this is test number 1. We forgot to mark the position of the reed switch, so we have no idea where it is inside the hilt. So we will just touch stuff until we figure it out.
Oh! Oh!
Okay, it's not full extension. Okay, so that's test number 1.
More like what didn't go wrong. When we finally got to testing, basically everything had a problem. First, we somehow kept switching up the polarities for the motors, so we had to resolder every single motor in our circuit. We also had problems with the blade not fully extending. We also had problems with the blade not fully retracting. We had components breaking.
The extension piece broke off.
We had more components breaking.
That is a fragment of a gear.
The blade kept doing this wobbly, swirly thing due to resonance and critical speeds, and through it all, I was getting increasingly worried. Why worried? Comic-Con. I booked tickets and flights to New York Comic-Con to show off this lightsaber in person, but the lightsaber wasn't working, and we were getting closer and closer to New York Comic-Con. I realized it was time to lock in. With lots of problem solving, we eventually started having small wins.
Electronic verification is done, everything's connected, everything is working.
You're great.
After rewriting some code and lubricating the blade pathway, we got the blade to fully extend.
Oh my gosh. That's it.
Oh wow, that is crazy.
After switching gear ratios and using a stronger motor, we got the retraction to fully work. By adding power limiting in the code, we stopped burning out our components. By redesigning weak gears and reprinting with stronger materials, the gear stopped breaking, and eventually, by adjusting the rotation speed of the inner chassis, we solved our critical speed resonance issue. After over 100 tests, we finally got the saber working.
Okay, has swing noises. It retracts fully inside the hilts, as you see. Yeah, pretty cool. Alright, people.
Literally 2 days before my flight for Comic-Con. Relieved and sleep deprived, I headed to New York for Comic-Con, but of course, the lightsaber broke in transit. Problem is, I think we broke the lightsaber during transit. So you can see the cane is sticking out. That's not supposed to happen at all. So already we know something's a little bit wrong here. Ordering last minute repair tools to my friend's place in New York, I stayed up for hours to fix the lightsaber. After hours of soldering and gluing and reassembling, I finally fixed it and showed it off at Comic-Con.
What? That's so cool! You're awesome. You are awesome.
Is this your first con?
First con, yeah.
Oh, what do you think of it so far, man?
So, retractable lightsaber. Yeah. Incredible.
So it's coil? That's insane, dude. What actually, dude, that's amazing.
This blows this out of the water.
Whoa!
Dude, that's so.
This thing is awesome. It feels more than ever like a real lightsaber. Like before, it's honestly quite hard to swing. The spinning creates this intense gyroscopic effect, which is accurate to how a real lightsaber is supposed to feel according to lore. Now, what's next? I'm going to continue improving the performance and reliability of this design. We also want to make it fully dual capable. Right now it can withstand light hits, but I want to stabilize, stiffen, and strengthen the blade even further. We also want to optimize the design for ease of assembly. Right now it's still pretty hard to put together, but we want to make it as easy as possible for anyone to make it themselves. Finally, we're going to work on porting this design into other existing hilts, along with different blade colors. Like always, the design files, material links, and full technical breakdown for this project are free for the first 48 hours after this YouTube video is posted. After 48 hours, only HeroTech members on our website or our Patreon have access. Subscribe to the channel and hit the notification bell if you don't want to miss out on future projects. Overall, I'm really happy with the progress on this lightsaber. I still find it kind of crazy that we were able to fit everything into this tiny hilt. To be honest, back in 2022 when I started this project, I didn't even think that fitting it into a replica hilt was possible. So back then, we didn't even try. Maybe we could have gotten to this point much sooner if I had believed it was possible, that we could do it. The whole point of HeroTech is that we bring the impossible to real life. Taking on this daunting engineering project, I somehow forgot that. I shouldn't have. So from now on, I'll make sure to remember that anything is possible. I hope you do too.